Okay, so today's notes are on factoring trinomials when a is equal to 1. So our content objective is to factor quadratic expressions in the form ax squared plus bx plus c when a is equal to 1. Our language objective is to use the correct terminology to explain the process of factoring quadratics. So backing up for a second, a trinomial, as we talked about last time, binomials have two terms, so a trinomial, tri means 3. So that's why a trinomial, this has 3 terms or 3 parts. Ax squared is 1, bx, and then c. So today we're going to factor when a is equal to 1. Our first example is right here. So our first step to factoring when a is 1 is identifying a, b, and c. So I'm going to use that information. I have to check, does a actually equal 1? Because the process we're going to use is going to be slightly different if it's not, which we'll learn about later. So check, does a actually equal 1? So I'm looking at the coefficient of x squared. So notice that a is the coefficient or the number next to x squared. So if there's no number written, it's implied that it's being multiplied by 1. So I know a here is indeed 1. B here is going to be the coefficient or the number next to x. So b is going to be 9 in this case. And then c is our constant or the number without a variable. So c here will be 20. So identified a, b, and c. That's my first step. After I do that, I'm going to find the factors of c. That sum or add to b. So that's why I need to check that a is 1 so I can use this method. And now I'm going to use b and c by finding factors of c that add to b. So what are factors of positive 20 that add to positive 9? So if you want to list all the factors you can, so I know 1 times 20 is 20, 2 times 10 is 20. It's not divisible by 3, but then 4 times 5 is 20. These, if I added them together, will give me 9, which is what I need to make sure that they add to b. So 4 and 5 add to 9. So what I'm going to do with those two factors is write them two binomials that have the factors as the second term. So I'm going to write two binomials. So I'm going to start by making my parentheses. Positive 4, positive 5. What's going to go in front is just x, with x as the first term. So I'm going to write two binomials that have the factors as the second terms with x as the first term. So here, what I can do to check, if I'm not sure if I factored correctly, we can do exactly what we practiced last time and use the distributive property. So if I wanted to check, I can take x plus 4 times x plus 5, and I'm going to FOIL. So I have x squared plus 5x plus 4x plus 20. I combine my like terms and I get x squared plus 9x plus 20. That indeed checks out. So my answer was exactly what I found. X plus 4 times x plus 5. So that's how we factor when a is 1. We just find factors of c that add to b and make two binomials. So I'm going to have you guys try that on your own really quickly with a quick check. I want you to factor x squared plus 14x plus 40. So try that one on your own. Pause if you need to. I'm going to go over it now. So I'm going to find my factors of 40. I have 1 and 40. I have 2 and 20. 3 doesn't work. I have 4 and 10. Those ones indeed add to 14. So I'm going to write x, and then write my two factors in. So plus 4 plus 10. So that will be my answer. If I want to double check it, I'm just going to use my distributive property. So I'd have x squared plus 10x plus 4x plus 40 combine like terms, x squared plus 14x plus 40. That indeed checks out, so my answer was correct. All right, there's one other little thing I want you to watch out for when you're factoring these types of trinomials. So I'm going to flip the page to show you what I'm talking about. So the next example I want to do involves one added little step that also ties into what we were doing last time. So I want us to factor, this time it's going to be negative x squared plus 13x minus 12. So here, if you wanted to start by identifying A, B, and C, you'd see A is -1, B is 13, and C is -12. The method that we just practiced doesn't work when A is not equal to 1. So what I need to do to make this work is factor out the number in front. And this will only work if every term in here is divisible by the number in front. So I'll show you what I mean. Step 1, I want us to factor out -1. So before I identify A, B, and C, I'm going to factor out -1. So I'm going to have negative, I'm dividing each term by -1, so that becomes, inside the parentheses is positive x squared minus 13x plus 12. So I'm factoring out the -1 like we practiced last time. So I divided each term by -1, wrote it out front. I didn't need to write the 1 because that's what the negative sign implies. If you want to write the 1, you're more than welcome to. You just do not need to. After that, I'm going to factor per usual. So I'm going to identify A, B, and C. So I know A is now 1. So I'm ignoring that negative sign for now. I'm going to write it in my final answer, but I don't need it for this part while I'm factoring what's inside the parentheses. So B is -13, C is 12. Factors of C that add to B. So factors of 12 that add to -13. So this is a little bit tricky because I have a positive number that adds to, or a positive thing that is multiplied to get, and a negative number that I need to add to get. So the only way I can have a negative number that they add to and a positive number that they multiply to is if both of my factors are negative. So let's try this out. I would have, instead, since I know they both need to be negative, I'd have -1 and -12. And those actually do work, so I don't even need to go any further. -1 and -12 are going to be my factors. So then I'm going to write my binomials. So I'm going to have x minus 1 times x minus 12. The only thing I need to remember is this number in front that I factored out, that -1, needs to come down and be part of my final answer. So that negative needs to be included in my final answer. So I have to include the -1 in front. All right, I'm going to have you do one quick check that is the same sort of process. You'll see what I mean. So I want you to try this one as a quick check, but I will definitely go over it. I want us to factor 4x squared plus 20x minus 56. So try that one out. I'll go over it. So again, just like we factored out the -1 here, I see that A, B, and C are all divisible by 4. So just like we practiced in our last lesson, I'm going to factor out my GCF of 4 to start. So I'm going to take, just so you can visually see what I'm doing, 4x squared plus 20x minus 56. I'm going to divide each term by 4 from the outset. So I have 4, and then what's left in parentheses is x squared plus 5x minus 14. So -56 divided by 4 is 14. Now I can factor this per usual. So I know A is now 1 because I'm ignoring the 4 in front. B is 5. C is -14. So now it needs to multiply to a negative but add to a positive. So I'm going to list my factors of 14. I have 1 and 14. Since they add to a positive, I know the lower number will be negative. I have -2 and 7, which those ones, indeed add to 5, so those will be my factors here. So I'm going to write my factors as x minus 2, x plus 7, and then the 4 that I factored out needs to be included in front, and that will be my answer. Again, I can always check by foiling and distributing or redistributing it out and making sure it makes sense. But that's all for now. I'll do one last quick check if you really would like it, but if you want to be done notes now, you can turn it off. But I'll do one quick check for those of you that would like a little more help. So I'm going to write 9x squared plus 9x minus 18. So if you want to do this one, I'll factor this now. So I notice that my GCF here is going to be 9. I'm going to divide every term by 9 from the start. And I have 9 in front and then x squared plus x minus 2. So then my A is now 1, B is also 1, and C is negative 2. So my only factors of negative 2 are going to be 1 and 2. And the 1 would have to be negative if it's going to add to positive 1. So I know that that 1 is negative, that 2 will have to be positive. So then I have x minus 1, x plus 2, the 9 has to stay in front, and that will be my answer. All right, make sure you write down any questions, comments, or concerns you have on this process so we can go over them together in class.